Presentation. I'm aware of my heavy accent, so if someone wants me to speak, repeat what I'm talking, just ask it. I'm about to introduce the infrastructure Rastro, the Alencar company is using here at our university. We are in Laboratory of Scientific Computing and Visualization. This is the laboratory Professor Eduardo Seton earlier told you about that Petrobras has financed. Second slide. I'm not sure. Where is this slide? I'm not sure you know Alagoas, but well, it's a kind of Caribbean place in Brazil. It's just like warm sea. I live there at that point. Next slide, please. Our team, I could not put everyone's name here, so some is missing. I believe we have two main researchers in our group. Professor Alejandro Ferrari, he's a world leader in image processing, computer vision, and satellite imaging. And Professor Osvaldo Rosso, he's coming to join our university. He's a world leader in entropy, information entropy, complexity analysis, and so the rest of our stuff. A very interesting thing is our group is a mix of computer science people and engineering people. So next. Okay. Okay. Next slide. Next slide. Okay. So what I'm talking to you will be about our laboratory. We're part of the Galileo network, who's sponsored by Petrobras, and it's a thematic network from scientific computing and visualization. It's a series of thematic networks sponsored by Petrobras for research applied in oil and gas. In particular in the pre-salt, I believe you know, everyone is aware of. Next. They built this Galileo system, which is a terascale environment to perform computational mechanics problems applied to oil and gas industry. This is a system they really use in research and production at Petrobras. The computer facilities we have here, the main computer facilities, this cluster from this Galileo network. When we inaugurated this machine, was the largest machine in Latin America. It was the second largest machine in the South Hemisphere because of there's a cluster in New Zealand for handling the Lord of the Rings. So it was the second machine when we have it. Now it's about the 15 or 20 more powerful supercomputers in the South Hemisphere. Next one. I'm sorry, I don't know what to look. So we have a visualization collaborative room, which is we have a 3D. Most of our rooms has 3D infrastructure and are supposed to be used for engineering projects. So engineers really use these 3D projections to get into their projects. So we have a world-class infrastructure for this kind of work. Sorry, it's in Portuguese. I didn't have time enough to translate it. But these are some projects. Most of them from Petrobras, but also from Impex Corporation. I believe it's a Japanese oil company. There is also projects from Embraer and Vale do Rio Doce. There are Brazilian companies. And what I can say is this, one of these projects, the first one, has paid for the cluster in the first 3 months. Just the use of it, it's like you're saying, sorry, it's in Portuguese, but this system is used to model the drilling of the pre-salt. So next one. Again. So, well, there's just an estimation of them because they used our cluster and how much time they saved for using it. From billion of years on human being for months or on a desktop computer to 19 hours, 30,000 analyses in our cluster. Next one. Another research area here, there's finite elements to model risers. Risers are the pipes who take oil from the marine soil and get to the ship or to the platform. So next one. You can pass this. This is a kind of, they're estimating how much does it take for a model in a computer and within the cluster. You can go through it. We also use finite element method to model the way we can fix the platforms in marine soil, and also we're starting to do some discrete element modeling in geotechnique and to prevent the sliding from hills. Next one. This is in Portuguese, but I believe you can read some of the terms there. We got programming in OpenMP, CUDA, MPI, hybrid programming. This is kind of the kind of programming. Well, how can I say that? Our students and researchers use these technologies and programming techniques for parallel and high performance computing. Next. This is another project also developed here this is from material science. They use it to link the ships with, they call it mangote. I don't know the name, but the problem is it's used for liquefied gas, so it has to be very strong to not and must support these very low temperature stresses. Next one. These projects I showed, they're kind of outdated. They're from 2 years ago. Some of them are concluded. Others, new ones are running now at our lab. We have this is just for HPC and grid computing. We have some collaborations. We have the Galileo network. We have this COCADA. It's a network of universities in Brazil and Northeast related to HPC. We have some partnerships with other universities and research groups. We also tried some projects. Some of them are concluded. Some of them are halted, like establishing a continental grid between Alagoas and São Paulo. It's like the distance. It's like East Coast and West Coast United States. So establish a grid of this size has some problems. So next one. We use also some experimentation in opportunistic grids and InfiniBand architecture within our cluster. And I believe this is smarter to tell. We are a university, so we are very focused in human resource training. We have some, what we'd say, minimum core for high performance computing. We want our students to learn. And we have also some network, how would say, network initiatives to to form qualified human resources, since the technical level to PhDs on this area. So, let's see. So this is also, Petrobras is also worried about human resources, because there is a shortage of qualified human resources also for Petrobras. So they invest in this network for this also. You can go faster. Go faster. Go through this. Now, I'm going to talk about some projects we are currently running in this lab and in LCCV, and also in another lab called Lacan, also in this university. One of this, I put some approximate amount of money from the grants. The first one I talk about is about smart building. We are currently in this collaboration network with several Brazilian universities. This is, well, the project itself is about smart buildings, monitoring, optimizing some resources, optimizing, tracking people, security issues, and other stuff. In my personal view, when I showed this talk to the people on this project of smart buildings, a smart building is the one that you ask a cup of water and the building itself brings to you. So I put some Rosie from Jetsons. We're almost to get to this point. I believe in the next 5 or 10 years you'll be there. This is some medium to big projects we had in the last 5 years, I think. Some of them are done. Go to next. This is a list of, not all, there's some missing, but active projects we have now. From the budgets are in real or dollars. Some small projects we currently running. Next one. The other lab I told you, this smaller lab than this, Laboratory for Scientific Computing and Numerical Analysis. This is kind of odd. I'll not show you the movie, but we developed a natural interface using simple kinetic to view finite element modeling. We can manipulate it using gestures and voice. We can make it useful for the engineers just to manipulate using their hands. A structure they can zoom out, they can detail whatever they want. So it's a kind of Minority Report project. It's currently going on. It's solid in our lab. This is a small server. Was the last one we bought just to keep our cluster updated. This is a server where Rastro, I think, is running most of the statistical simulations. So we have a 16-core. They used this small server for the first experiments. Now the second round is the big cluster. Yeah, exactly like that. When you put a 1,000-fold increase in the number of tests, you have to use the large cluster. So next one. We had some prototypes on remote visualization. I can see in my tablet renderization of this cube is 1 million particles. We render it at the cluster and send the image for a laptop or a smartphone or a tablet. Next one. We also have a project for a video wall of high resolution. We have it running in small scale, it's just experiment, but we're trying to get funds to build a video wall. This is what I talked about. We can do large data sets, remote visualization and manipulation. It is what they call remote scientific visualization. Next one, sorry. For about this, I have to join some. This is project that's halted in virtual reality. Virtual reality. We have some contact with people from Sun University at New York. This is currently not running, but we intend to do it in the near future. We have some wireless sense network experimental group. We are currently working with point cloud natural interfaces. Go on. We also have 3D printing for haptic prototyping. This week we're starting this new one. We also about to buy autonomous unmanned ground vehicle, and also a LiDAR, a high precision LiDAR. Next one. And we also, sorry this is in Portuguese, but we also have applied for a grant in smart grid. Maybe that mattered for you. Next one. This is a project we applied. Well, I researched some state of the art. As you can see, there's protecting consumer privacy in smart grids is already a issue, because we can identify by the use of electric equipment who's in the house at any moment, who's doing what, whatever. So privacy is now an issue for smart grid technology, and we do that by no intrusive monitoring. I mean that I put in I only measure the entrance of the residence, and I can know everything about what's being consumed there. So it's a new field. And at this point, I believe they already talked. These labs, in particular Lacan, was the birthplace of Rastro from José Alencar. Professor Alejandro Ferri was here master supervisor, and also have some companies who came for our help to develop projects like Nix Knowledge, and also one startup I'm participating with some students of mine called Indenbox, are the most recent ones. Next. And what we developed here from my startup and from the project with Nix Knowledge is Transpetro looked for us for a way of manage this naval fleet. So we have developed all the technology here in Maceió, so they can control their crew using biometry, their supplies on the ship, and whatever. They can do it in the middle of the sea. They can communicate. This is a kind of new technology I couldn't find an equivalent in the world. So we're currently installing it at Transpetro. Is half of the fleet, I believe now, it's equipped with this technology. Go on. In this technology package, we also built a National Center for Control of Maritime and Hydroviary. It means all this fleet from Transpetro is now controlled in a single room at their headquarters in Rio de Janeiro, and they know everyone who is in a ship, the state of the supplies, the machines they have there. They can control everything from a single point. Next one. This is the current product they're using, called Safe. You can see there was in early stage this picture. You only have five ships, and they also communicate a thing that's quite new. They also communicate the localization, also the localization from the surrounding ships of each ship from Transpetro in anywhere in the world. And they have reports on everyone. Seaport visits the ships, the crew, the visitors, and everything else. Next. So we have some expertise in smart cities and traffic, also logistics. Next one. And to close my presentation, we have opportunities here. We have, how could I say that? We have more projects available than people to work on it. We have undergrad and grad student scholarships. We have positions for visiting researchers and students, visiting professor, postdocs, people from companies who want to get a stage here. We also have funds for that. So I think it's all. Husks are red here. So it's it. Any questions? So thank you very much for this opportunity.
Thank you very much.